and you'll see why it's quite different as we get through it. Just a little bit of housekeeping. Who am I? So I'm an assistant professor at BI. I've been here for around like 2 years. I'm very happy to be here. And I'm also an associate research scientist at the Max Planck Institute for Human Development. We do decision-making research. So if you have interest in that, so more based in terms of psychology, feel free to reach out. I also have a background in computer science. So my background is computer science and psychology. Which is one of the reasons that data science and data analysis has been a very big passion of mine for a long time. And unlike most people, it is my favorite part of the research process. So I'm excited to kind of share a little bit in terms of how I think we can look at data analysis and specifically how we can use R in maybe an easier and maybe more efficient way than other kind of workshops. If you have any questions at all about the content of the talk, or just want to write me an email to chat about things, you can do that. There's no question that is too small or too stupid. If you are getting started with R and you're having trouble getting RStudio to work or loading in some file, you can literally ask me. That is totally fine. That's in a sense what I'm here for, right? The project files for this seminar are on OSF. They're open source files. I'm going to give you this link in the Zoom chat. One second. How do I get to the chat if I'm sharing? Okay, whatever. It's going to be a little chaotic. I'm going to be going back and forth a lot. So here's the link for the OSF link for the materials for the workshop. You do need to go there. There's a couple things on there that are important for the workshop. So there is a CSV file that we're going to be using. There is an R file that is kind of the end product of what we'll be doing. And then there's also my slides. And I think the best thing to do would be actually to download the slides from that OSF page. And then just follow along with me as I go through the slides. So yeah, it'll be a lot on your screen, but it'll help a lot because there's a lot of links in the slides and little snippets of code and things that you're going to want to click on or copy. And it's going to take a lot longer if you have to manually type out URLs. So I'd very much recommend downloading the contents of that OSF page. If you have any issues with that, just unmute and yell. But it should work quite well. All right, so I'll head back to the slides. Cool. So what we're going to be doing is an introduction to R. As I said, it's a little bit of a misleading title, and you'll see why. Why R? So just kind of starting with why are we even going to use R? There's tons of different softwares. What's so special about R? Why does everyone seem to use it? Of course, there's things like SPSS. They cost money, but they're fairly easy to use. I actually think SPSS is wonderful. I don't really like the whole stigma in the community of R users that SPSS is lame and for beginners. I actually think it's a wonderful software. And in the past, I've done little, data races with colleagues in different workshops. And if I use SPSS, I usually win because it's extremely efficient and the kind of click and point is very fast. But it's limited in certain senses, right? So it's not particularly flexible. The visualization and graphing is horrendous. so there's moments where you will eventually be forced to use R, and maybe that's why you're here. Things like Excel, online calculators, I don't think we have to talk about. They're obviously very limited. There's, of course, other options like SAS or SAS and Python, which I think are also good options. But since the kind of industry standard a little bit is to use R, at least having a little bit of foundation and background in it and understanding how to use it is probably quite important. So R is free and flexible. That is what makes it so powerful. What I mean by that is, first of all, it's completely open source, doesn't cost anything. So it is literally free. It was created for social scientists by social scientists. And it's extremely flexible. So If you're going to do an analysis that is maybe not perfectly cookie cutter normal, you will probably have to use R, right? There's thousands of packages to use different types of analyses, micro to macro, macro to micro, like all these different things, like different forms of reliability and all these other things that, a reviewer might ask for on a research paper. You'll be able to do in R and not in a lot of other softwares. So that flexibility is what makes it so powerful, and that open source nature of everyone contributing and continuing to contribute makes it an extremely powerful tool. It's quite difficult to use though, right? The learning curve is very high. And this is what really is kind of the negative about R, is that it involves programming, it involves coding, and those are maybe not the tools that we have learned in the past as social scientists. So it definitely is a bit of a learning curve, and it's a difficult program to use. I also will give you an example of why it's difficult to use even as just a programming language. So from computer science, there's kind of a rule in creating programming languages, which is that you want the programming language not to have a million different ways to do or say the same thing. This is very similar to a normal language like English, right? If I had 25 different ways to describe one type of chair in English, that would suck. It would be hard to communicate about that chair with somebody else. And R has a little bit of this problem because it was created by social scientists and not by software developers or computer scientists, which is that there's many different ways to do the same things, which is a serious drawback in terms of R, and makes it quite a bit more difficult to use. So again, I don't want to scare you, but the learning curve is pretty high, and it is difficult to use. We don't want to sugarcoat that. So the usual introductions to R and what I had actually originally planned to do, it usually involves, so I've co-taught a couple R courses, and the first class or two usually involve being like, this is a data structure and data frames, and this is how you assign a variable, and there are all these kind of minutiae things. But I realized, if we only have these 1.5 to 2 hours, doing that is really not going to do anything for you, right? You're going to leave and you're going to be like, oh, well, I guess I think I remember how to do that one thing at the start and read in a CSV file, read in a data file, but that's like all I kind of remember. So it's not particularly helpful, right? We need to actually like have a full class for you to feel somewhat comfortable with R. Again, it's difficult to learn. So I kind of spent a bit of time thinking about, well, what should I do instead? Is there a way to make things kind of easier, more efficient? So one thing that we'll always have to do in an introduction to R, and that's download RStudio or some other editor that you can write R code in that compiles R code and that presents you with some kind of output. So that's going to be true nonetheless. The usual experience is to have students do that, and then they experience pain. So basically, students get very upset because they can't load in the file, they can't find the file. There's a parentheses missing somewhere, and it's causing everything to crash. And it's just not a nice experience, and it creates kind of a negative association to R and coding languages generally. And we kind of want to avoid that. This is me trying to integrate into Norwegian culture, by the way, by adding this group. So in any case, the idea is there a way to be better and turn the poor scream upside down and surround it with puppies and make it happy? Although, personally, I think this image might be creepier than the original scream. Is there a way to make the experience of R and learning R and kind of the beginner part of R more efficient, easier, and less kind of daunting and painful? And the way we're going to do that is we're actually going to combine R with artificial intelligence. We're going to see if we can use artificial intelligence to kind of have a beginner jump into R and to use R without actually having to really code anything. This is fun. So we're not going to spend today, writing little bits of code that are fairly complicated, and then, everybody on Zoom yelling, being like, it doesn't work, what's happening? Instead, we're going to see if we can use artificial intelligence to write our code for us to analyze a data set without actually having to code at all. Pretty neat. So that's why the title was misleading. It really should have been how to use AI in R. So I'm sure you're familiar with artificial intelligence, right? Lots of things in the news lately. ChatGPT is kind of blown up in the sense that we seem to have created something as cool as a time machine, but we still are kind of like, what is happening? But I think it's very exciting. There's also artificial intelligence that is specifically made for creating code. So when we think of ChatGPT, right, it's just this kind of conversation. We ask it anything. Our students ask it to write their introductions to our papers. But there's also artificial intelligence that's specifically designed to help you write code. And Better Code AI is one example. It actually doesn't even require any kind of login or anything like that, which is quite neat. So going back to this idea of R is free and flexible, which is huge pluses, right? Huge positives. You will probably have to use R at some point if you have a data analysis question that is semi-complicated, right? That is not just the basic of the basic, but it's so difficult to use. But if we can solve the difficult to use part, if we can solve that kind of learning curve, then I think we can make R a lot more accessible to people, and also accessible specifically to people who might not have that much of a background in coding or have coding skills or whatever you want to call it. So I think there's a real opportunity here to kind of integrate AI into R and provide students and other researchers the opportunity to kind of use it more efficiently and more easily. In other words, artificial intelligence makes life easier. I think this is such a stupid image because eventually it'll make life more complicated, right? Okay, here's some fun examples of AI just because I couldn't resist because, you know, they're just really fun. This is this is not a person, so this is not a real person. These are people created by artificial intelligence. They look super real, right? But they're not. Kind of a fun source of stimuli if you're studying faces, by the way. Really neat. I mean, this is pretty trippy stuff. This is a bunch of avocado chairs created by DALL-E, artificial intelligence that creates images. In case you're in the market for an avocado chair, here are some designs that you can suggest to you know, a designer to create or a company to create. I really, you know, I've been inspired by this and I kind of want to get an avocado chair now. But this is created by artificial intelligence and it's pretty neat given the variation in the different avocado chairs. The next is a video and it has sound, but Zoom has gotten so good at blocking out any other sound than my voice that I might not play that sound, but who cares? It might also play the sound, who knows? So this is quite fun. So it's fun to include a short rap video and a talk just right off the bat. So this is a song by Drake featuring The Weeknd, except that it's not. It was created by AI and released, and it became viral, and everyone thought that they had released this cool single that people really liked. And it turns out the entire song is actually just created by artificial intelligence, which, I mean, whew, that's fun. Okay, so if artificial intelligence can do all these things, why can it not help us to code? Why can't it help us do our data analysis? And I think the answer is it can. It obviously should. But we're not really using it yet, and we're at the baby stages of this. But there's definitely the ability for it to help us. There's definitely the ability for AI to contribute to our data analysis. And not just other areas of research. I'll give you one example. This is on Replit. Replit is an online IDE. That is a fancy way of saying it is an online program where you can write code, compile code, run code, see the output of code. This program is in Python. And you will note that in this example, I will not code a single thing. Instead, I will ask Replit to code for me. It has an artificial intelligence that is called Ghostwriter. That is around, I think, $15, $20 a month or something. So I'm not sure if that's worth it monetarily, but I'll give you the example. So this is me on Replit, and I'm going to show you this fun example where I'm going to generate some code to draw rotating colorful circles in Python without actually writing any code. So I'm just going to write that in English and check it out. It's going to create the code for me. Boom. Holy shit. I think this is awesome. This is incredible, right? This is something that when I was a computer science student in my bachelor's, all my peers and I would have killed for. Our homeworks were things like this, right? And now we can just type it in English and generate the code and it does it for us. That is shocking. It also makes me feel better about not getting into computer science because maybe my job will be gone here. So that's just an example. So let's go back to R because that was Python, right? That was not R, and it's just an example of using artificial intelligence to code things. And we can go through this tutorial that we're going to do today, where we're going to see if we can code an entire data analysis. I mean, it's not going to be super long, but a short data analysis, only using artificial intelligence. So we're not going to code anything. So what are you going to learn? You're going to learn how to use artificial intelligence to code in R. And you're going to learn some basics about mixed effects modeling. The example or the content, what we're going to analyze, is some data that requires mixed effects modeling. And I chose this because mixed effects modeling is kind of the standard now in terms of data analysis. If there's anything that's more complicated than kind of a linear regression. Because it's very flexible. It's able to do a lot of different things. It's able to take into account grouping variables, right? So let's say like states or communities nested in countries, or students nested in classrooms, nested in schools, right? It's able to take into account multi-level data. And it's able to take into account repeated data. So repeated measurements, right? If I measure how, Billy and his friends are doing today, and I measure next week and the week after and the week after, right? If I measure the impact of some intervention, I'm going to have repeated time points. And mixed effects modeling allows for that and is very powerful in terms of modeling that kind of data. So anything more complicated than kind of a straight correlation or linear regression or multivariate regression is going to be a mixed effects model. So I think it's a perfect thing to kind of learn in this workshop as well, kind of an added benefit. Then I'm going to finish with some warnings about the future and kind of what not to do, and also some thoughts of what is kind of right now, what is at the forefront of artificial intelligence and R specifically, and how can we utilize that to be at the kind of the forefront of our fields and the forefront of data analysis, right? We want to be the best. We want to do a good job in our data analysis and our research. We want to be efficient, and I'm going to share some tools with you that you can use to do that. Okay, how are we going to do all this? We're going to use the Dragons workshop. The Dragons workshop is super neat. It is an introduction workshop to mixed effects models. Honestly, I go back to this workshop all the time when I get lost in what I'm doing in my mixed effects modeling, or when I run into problems or have questions. It is by far the best resource I have found on the internet in terms of learning about mixed effects models. It's just very clear and very informative. And what we're going to do is we're actually going to redo that workshop, but we're going to do the entire thing without coding. We're going to try to recreate the code that is created in that workshop, simply only using AI. Super neat. It's going to be fun. Okay. Some credit. Gabriel Hajduk developed this workshop. It's super cool. There's a link here on this slide. You can go, and I recommend that you do, if you have time, go through the full workshop later. We're only going to cover part of it today, but it's really fantastic. So I really recommend going to that and reading through it. It's not too long, and it really will help in terms of understanding why mixed effects modeling is important and how to do it in R. Cool. So mixed effects models, what are these things that I keep talking about anyway, right? So I asked ChatGPT to tell me what they are. I know, shocker, more artificial intelligence. It said mixed effect models are statistical models used to analyze data with correlated or clustered observations. They have both fixed and random effect variables and can handle a variety of applications such as longitudinal data or complex sampling designs. both flexible and provide a framework for modeling both within group and between group variability. This is a really good description, actually, right? Like if you know some of these terms, this is like pretty spot on. Just to unpack it a little bit further, right? Things like fixed and random effects might mean nothing to you, or clustered observations, like these things might be kind of foreign concepts. So let's just step really quickly through what mixed effects modeling are in a different, maybe more approachable language than that was created by ChatGPT. So one thing they do is they account for grouping, nesting variables, and dependence within our data. I'll give you an example. If you're looking at how, let's say, teacher attribute, right, predict student performance. Let's say that's your sample, that's your research question, and you collect teachers and students in different classrooms, but also in different schools, right? You have a grouping variable or a nesting variable in the sense that your students and your teachers that you collected are distributed across different classrooms and across different schools. So there's variance in those different classrooms and different schools that matter, right? This is not fully randomized in a sense. There is dependence among the different instances of the classroom or the school, right? So we want to account for that variance, right? Because it's a lot of noise. And we can do that with mixed effects modeling. And by doing that, we really increase statistical power. And what I mean by that is we increase the chances that we find an effect if it exists, and we decrease the chances that we don't find an effect if it doesn't exist, right? So did I say that wrong? I think we decrease the chances. No, we increase the chances of finding effects if they exist, and we increase the chances of like claiming a null effect if effects don't exist, right? Cool. So how do we do that? We account for random variance, right? We're able to partial out all that noise that comes from classroom and different schools, right? One school might be in a different location. You can also do this example with like a country level analysis, right? You're looking at people in countries or people in communities, and you want to partial out the random variance that comes with being in one country versus another country, et cetera. And for that, we need to use mixed effects modeling for any kind of multi-level data like that. As I mentioned earlier, mixed effects models also allow for both within participants and between participants data or measures. So if we collect our students, every month we check their performance, then mixed effects models are able to handle that, are able to analyze that. So if you have any case where you have kind of repeated measures over time, let's say, or just over person or over instance, right? Those are all going to be dealt with by mixed effects modeling. So most of the data we work with, because it is messy, right? It is stuff that, if you go into a company and you ask employees certain things and whatever, there's going to be a lot of kind of random factors like what work group they're in, what office they work in, whatever it is, and we can control with those with mixed effects modeling. So for most of the things that, most of the research we do at BI, I think these models apply and not much else. So that's quite I think they're really just the base of what we should be doing. And then things get more complicated from there. But and that's why I chose it for this workshop. So what is the Dragon Workshop? So it turns out that we are dragon trainers. So we live somewhere in a remote mountain range, and we have been training some dragons. And what we want to know is whether the length of the dragons predicts the dragon test score. So let's say, the test score is some test score of how, how many flips the dragons can do and, how fast they can fly or whatever, I don't know. And what we want to know is whether dragon length predicts dragon test score. We want to pick some of our dragons, let's say, and go to, the competition with the other dragons from other places or whatever. And so we want to be able to predict test score. And let's see if, dragon length, how long the dragon is, predicts their performance. Importantly, in this sample, we've collected multiple samples from 8 mountain ranges. So there isn't just one mountain range where we went and collected some dragons to measure them. Instead, the dragons live in little communities on different mountain ranges, much like the students in the different classrooms and the different schools that I mentioned earlier. And that makes this kind of multi-level data, or at least nested or grouped data. we need to take that into account, right? We can't just necessarily ignore that they come from these 8 different mountain ranges. And you'll see exactly why we can't ignore that in this workshop. This is what the Dragons data set looks like. There are 5 columns: test score, body length, mountain range, X, and site. You can ignore X and site for the purposes of this workshop. If you do the full Dragon workshop, in that link I showed you earlier, they become relevant, but for us, they're not going to be relevant. So there's just 3 variables we care about, which are test score, body length, and the mountain range. Again, there's 8 different mountain ranges. Here, you'll only see one of them that says Bavarian, 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 right? Because I just took the first 7 rows of the data file. But if you go further down, there are the other mountain ranges. Okay, so let's get started. I need to switch the screen that I'm sharing real quick. 1 second. Okay, let's get started. To be able to do that, we're going to use Better Code AI. I originally wanted to use ChatGPT to do this, but it kind of is a little slow occasionally with different users. And so to have us all be together at the same speed, I think Better Code AI is better. Also, you don't need to log in. So we'll use ChatGPT later, maybe for a second, but for now, we're going to use Better Code AI. So just click on that link. And it will open. Can you give me a thumbs up if you can see the Better Code AI and it's not stuck on my presentation? Cool, thank you. So if you haven't downloaded the slides, you just type this into your URL, download the slides so you can follow along better. Okay, so this is Better Code AI. It's really quite neat, and I'll show you how it works. So let's say I want to do something. Okay, first of all, it says, hello, paste code in the editor, then ask me anything. I will improve your code, blah, blah, blah. And it gives you some suggestions of like things that are very commonly asked for, like write sample JavaScript code or write code to reverse a string. The write code to reverse a string is commonly asked for because that is always a homework in introduction to computer science courses. In any case, we can kind of ignore what it's saying. It's asking us to paste code and then it'll do stuff, but we don't want to code. Remember, the whole idea of this workshop is that I'm going to save you from coding, which hurts me to do, but it's also probably good in terms of efficiency's sake. And so we can actually just type into it and we can ask it to code stuff for us. So let's try something very simple, right? We can be like, write a line of code in R that adds 2 numbers together and saves them in a variable called sum. Oh, that's nice, right? That was pretty easy. And so you can see on the right-hand side of your screen, or my screen, well, I guess it's both our screens at this point, you can see that it's created this line that says sum is equal to 2 plus 3. And we can hit approve changes and create new version at the top left here if we think that it did a good job in terms of what we were asking for. So we do that. And that's very nice. That was a really simple example. Let's reset and let's do something a little bit more complicated. Can you please, right? We always want to be nice and polite. So can you please code full one-eyed bandit in R for me? By the way, one-eyed bandit is the thing in casinos where the gambling machines. It's called a one-eyed bandit because back in the day, right, you had that pole you would pull and you would be like, and then it would go back up. You can code a one-eyed bandit pretty easily. It looks like this on the right, and Better Code AI has coded the entire bandit for us, which is pretty cool. So it's basically coded a tiny version of a gambling machine. Right? It says at the top, define the symbols, cherry, lemon, orange, plum, bell, right? Like the little symbols that come down. And then it gives probabilities of them showing up. It even, I think, knows that the bell is worth more money, so it has a lower probability of showing up. And then it has these reels that it spins. It has this nice function. You spin the reels and it'll give you an output. I mean, this is pretty neat, right? This is like an actual nice bit of code. Here's the fun thing though. If I ask it the same thing again, can you write a full one-eyed bandit for me in R, please? And you'll notice something about Better Code AI and about these artificial intelligences, which is that every time the result they create is slightly different, which is kind of odd. It makes sense for artificial intelligence. It's not great for coding because it's always going to be a slightly different outcome. So that is something to keep in mind. You'll see the program is actually quite different. It has different aspects to it. It has the play function is different. It has different results. It kind of maybe says different outcomes. I did it once and I asked it to do this and it said, oh, jackpot or something as a print function. So it's always a bit different, which is kind of interesting. Okay, one last example. So right now we're asking it stuff and it's creating this code, but Better Code AI and ChatGPT, they're actually slightly more meant for like conversations in the sense that they learn while you're learning, and it's kind of a back and forth. I'll show you what I mean by that. So create a variable in R called pumpkin. And it creates the variable called pumpkin. I am a pumpkin. That's nice. Right, and I can approve changes. And then I'm going to keep working on this code, right? It's not a one-off. I'm going to be like, okay, thanks. Can you now create a for loop that prints out pumpkin a random number of times between 1 and 10? It actually removed pumpkin. Okay, that sucks for my example. So I should have said add. Let's redo that real quick. Create a variable in R called pumpkin code. And now it should add it. Yeah, so pumpkin is still there. This is a pumpkin. And then it's added a little for loop that prints pumpkin a random number of times. And I can say approve changes and create new version. And now I'm kind of talking with it, right? So I can also be like, can you add another variable called tomato? It's like, oh, okay, I'm going to add tomato. Like that's pretty neat, right? So I have pumpkin, approve the changes. It's added tomato at the top where the variable assignment is, and now it goes through and prints pumpkin and tomato. But it's a conversation back and forth, right? So that's neat. That's just important to recognize. Okay, so let's go back to the slides here, and let's kind of start the actual, part of the tutorial that involves you doing stuff. We only have a little bit of time left before the break, but that's okay. Where were we? Uh-oh, I'm lost. Hold on. Nope. Okay. So there's going to be 3 little tasks that we're going to do first. So the first thing you have to do is just open Better Code AI. And you're going to do what I was just doing. You're going to talk with it and try to create the following code. You're going to start by asking Better Code AI to create a code in R. And you have to specify that it's R, by the way, that installs these 3 packages, skips it if they're already installed, and then loads those packages. The second thing is you're going to ask it to add code that opens a window that can choose a CSV file. And the third thing is you're going to ask it to add a line that creates a histogram of the variable test score in Dragons. Use text that is similar to the text on this PowerPoint, right? You don't want to just only use part of the text or something because it's not going to create the full thing. And why are we doing this? We're basically recreating the Dragons Workshop script. So the R code in the Dragons Workshop using AI. So in that code, we need to use these packages and we need to load in our data, right? Our Dragons data. So that's what we're asking Better Code AI to do for us. And then, we create a histogram because we just want to see what test score looks like in Dragons. We want to see if it's normally distributed or not. So this is the part where I'll leave you on your own for a little bit, and you will go and try to do this. So play around with Better Code AI. for maybe the next, let's say 4 or 5 minutes. If you have questions, just unmute and ask them, or write in the chat. Happy to respond there. I'll also just share the URL for Better Code AI really quick in the chat. And then I'll keep up the instructions of those 3 things. The 3 tasks. Cool. Yeah, so have fun. And if you came late or something, you can go to the OSF page that is in the Zoom chat, and you can download all the slides and the Dragons data and all the other stuff that we will need. And if you have any questions, obviously just yell at me. I'm gonna refill my tea in the meantime. If you can do me a favor, which is if you're done, just put like, I don't know, the little thumbs up Zoom thingy, so I can kind of tell when we're good to move on.
Santa?
Yep.
I downloaded the Dragon Files and stuff to my desktop. But did you not want us to do that?
No, that's perfect. We're just not using it yet. At the moment, we're just using the Better Code AI and typing in those prompts. That's it.
Okay. Okay. Cool.
But yeah, no, we will use the Dragons file, so you do need to have it downloaded. That's right.
Yeah.
But for now, just use the Better Code AI and type in those prompts. So how's it going? Is anyone running into issues already?
No, it's just coming with improvements. Which was a bit like, oh, okay.
Sorry, can you repeat that?
When I prompted it to write this code, it came with improvements.
Right. So it offers improvements because it's a fancy little code AI. But you can ignore the improvements.
Okay.
But yeah, no, it has some fun improvements like adding comments or other types of things. I mean, I think it's a nice thing to have, but in our current situation, we know what we want, right? So we don't need to really use the improvements. Yeah.
I got a issue when it comes to the second point. Maybe I can share my screen.
Yeah. Hold on. Let me jump off mine.
Sorry. So I think the second one is to open like working the working route where I save the data file.
Okay, so I think where you went wrong is that if I'm not mistaken, you're currently in JavaScript. So in the first prompt, you really have to copy it from my text exactly because you need to say that you want to use R.
Okay.
Yeah.
Got it. I will try it again.
So I would go reset current version. So if you run into a mistake or a problem, go to the top left and say reset current version, and then you can start over.
Okay. But
you have to kind of use the exact prompts I wrote. I mean, not obviously the exact prompts, but you have to say it's R because Better Code AI does any language, and it tends to default to JavaScript. So you do need to specify that you want it in R.
I got it. Thank you.
Is anyone else willing to share what they have?
I can, if you want.
Okay.
I tried to run it enough. But okay, let's see.
Yeah, that looks good. We're just missing the install part. I'm not sure why
I
that.
already installed the bins before the course started. Do you want to do it again?
Yeah, I understand. Okay, well then it's fine. Yeah, that's fine. Okay, so let's I'll go to what it. Well, we can actually just run through it. So if you unshare, then I can share again, and then we can run through it real quick. Okay, screen. Okay, so create code. Bam. So we're just gonna copy that. We're gonna go to Better Code AI. We're gonna reset, and we're gonna ask it to do that. Very nice. And it is giving us this lovely code to check if the packages are already installed, and it only will install them if they're not installed, which is very nice. And then it gives us a bunch of extra information for funsies. And then we're gonna say, okay, I want to add to that. I want to add this line that opens a window, and it will update our code to include that line. So that line is going to be used to be able to load in our dragons.csv file. Looking good. And then if we were to add this last bit, and dragons, can't really see. Okay, then, all right, very nice, very nice, very nice, very nice. Okay, and for some reason it did not add it. Okay, approve and create new version. Let's try that again. Add a line to the code that creates. Let's try that. There we go. So we're kind of building the code together with the AI, right? Nice, so approve changes. So now on the right, you'll see here, that's exactly what we asked it to do, right? We asked it to install these packages and load them. Well, install the packages if they're not already installed. We asked it to load dragons, the CSV into dragons, but we use this little file choose thing because I don't know where dragons is on your computer. And so I can't ask the AI to figure that out, right? The AI doesn't have access to your local computer, so it has no ideas where you save Dragon. This little line of code is a line of code I use a lot with students when teaching R. What it will do is it opens a window where you can, like a normal like Windows or Mac window where you when you look for your files, and then you can go find dragons in your downloads or whatever it is and just click on it and it will load it in. It turns out that like loading in a CSV file is something that causes 30 minutes of stress in students. And this is kind of a hack to make it just so much easier. So that's why that line of code is there. And then the last line of code just creates this histogram so that we can see what the dragons variable looks like. Let's should we do our like 10-minute break and come back at 3? I think that sounds like a good idea, right? Okay, so let's do our 10-minute break and come back at 3, and then we'll do the data analysis part the same way that we just did this using Better Code AI. Cool. In the meantime, if you have any questions, thoughts, concerns, or if you're like way behind and you're like, I was texting my friend and I don't know where we are in the workshop, that's totally fine. Just ask me.
Anton,
Mhm.
are we doing, when is this finishing today? Because I have a chance, sorry.
At 4 p.m. I think we had a 2-hour slot.
Are we doing stuff beyond making the histogram?
Yeah, definitely.
Oh, okay.
I mean, that would be pretty boring, though.
Yeah, I already done that. Do you, can I just email you if I have issues and I'll give it a go on my own because I gotta take.
Yeah, absolutely, no problem.
Yeah. Thank you so much, though. It's so fun. I really miss programming. So you
There's
really,
also there's a resources thing at the end of the slides of ways, like different ways to combine artificial intelligence and R. So you can take a look at that too.
yeah, that's the juicy part I want to get to. Okay, pretty cool. I'll give it a shot in my tonight, and then I'll just let you know if I hit any.
Yeah, no doubt.
Yeah, thank you so much.
Thanks for coming.
Cheers.
Can I ask a quick question?
Yeah, of course.
But before that, just as a warning, I'm a really newbie. I'm a really beginner in R, so that might be a stupid question.
There are no stupid questions.
So here's my screen.
Yeah.
And I got all the codes and everything. I run it, but where's my output? Might be a very, very beginner question.
No,
I cannot
that's,
see anything.
that's
Nothing
totally
is happening.
fine. So okay. So I mean, yeah, you skipped ahead a bit. Because we're gonna get there. One thing
Okay.
that I can already tell is that I think you have like an R markdown tag. So like on line 12, I would just delete that little R thing.
Okay.
And line 24, I would delete that too. On line 12.
Mm-hmm.
So like in the script. Yeah, so you're in the script, right? In the untitled one. Yeah, if you scroll up. So you see on the left there, there's line things. At line 12, you have a little R thing.
Yes, this
The
one.
bracket. Yeah, get rid of all those. They shouldn't be in there.
Oh, okay. But I didn't add them. They just came.
I think you copied
Yes.
the R code from the better code, like directly, and
Yes.
hitting the little copy.
I see.
Yeah.
See.
And then
So
also
now,
can you on line 20 and line 22, you have like double install LMEs and they're already above, so you can delete both of them.
yeah. And these?
Well, if you already ran them, you shouldn't run them again, really, because that's just going to take a lot of time.
Yes. And now I'm trying it again.
So the reason it's getting stuck, one reason might be is that the read CSV thing, there is no file path. Like the file choose thing is not coming up, maybe.
Might be.
Or actually, no, it seems more like a syntax error. There's like a missing parentheses somewhere.
Might be. Okay, but it's overall looks
We'll
correct.
get to what it looks like.
Okay.
You just kind of jumped ahead. Like we're not in
Okay,
the
then.
studio yet.
Okay then. Thank you so much.
Yeah, no problem. All right, let's get back to it so we don't run out of time. Cool. So we should have something that looks a little bit like this, right? It's line 1 to line 13 here. So I'm just going to remove this stuff for a second. And if we run that, right, it's going to open this dialog box. And in that dialog box, we just have to go to our dragons and we open them and it does that. And then it should create our histogram for us here on the right in the viewer. Wow, it's in the plots technically. Right, so our code works, right? In the sense of the code that I just created, that you watched me create on Better Code AI. Cool. So let's move forward a little bit so we don't run out of time. What we're going to do next is we're going to do the same thing on Better Code AI, but we're going to have these 3 prompts. So we're going to add these prompts to our code. The first thing is to add a line to the code that creates a variable holding the standardized version of body length and save it as body length 2 in Dragons. We don't necessarily have to do this, but you know, in statistical modeling, it's often a good idea to center your variables for a variety of reasons. And so that's what that line of code would do. We then ask Better AI to create a linear model that's going to test if body length 2 predicts test score, and then is going to print the summary of that model. And finally, we're going to add a ggplot of the model with the body length as the x-axis and test score as the y-axis. So I'll give you a couple minutes to do that. And again, I'd recommend kind of copying in the exact text here. You can also try your own, but it's more likely that it's going to create what you want if you use the exact text here, because it's detailed and uses the language that it understands. So I'm just going to run through it with you. So we're going to add a line to the code, right? That creates a variable holding the standardized version. So I'm going to do that. Right, and I'm still using the original code here. If you deleted this or restarted, it's fine. You can just piece the code together. But ideally, it's all in the same place. Right, and I've added it here, 21, 22, and 23. It added code to create the standardized variable body length. It says Dragons at body length 2 is equal to scale Dragons $ body length. So it's basically just saying we're going to apply the scale function to the variable body length in Dragons. And then I'm going to approve that because it looks good. And I'll go back and then I'll add a linear model. And I'm going to improve. And you can see that at the bottom here, it's added the linear model or the line of code to test the linear model and the summary of the model. So this line basically just says LM, linear model, test score as the outcome variable, body length as the predictor, the data is Dragons, and the summary command here is a function call that will output the summary of the model when we actually run this in R. And then the last part is to add a figure of this relationship. All right, cool. And we're going to approve those changes. And now on the top right here, there's this little copy button. And we can select that and then move into R. and copy it in. So I'm going to delete everything here, and I'm just going to copy it into this space. And now we have this nice little code that artificial intelligence has written for us that we can run. If you select all and then run it, you will see the following. Again, you're going to have to choose the dragons file. It's going to create the histogram, and it's going to create this new plot. And the output of the model is going to be in the console here, in that area. It says, here's the call, right? Residuals, coefficients, and here's the predictive power of body length, right? Body length 2. For every change of 1 in this standardized variable, there's a change of 9 points in the test score, and there's a significant relationship. So that's how you read this little linear model. And you can go between the different plots using these arrows. So you can go back to the histogram and forward to the plot of the relationship, right? And very obviously here, our model is indicating that the higher the body length, the greater the test score. Does anyone have any questions about this or things they ran into? No? Okay. Cool. So just to summarize what I just said, right? What does the output tell us? It looks like body length positively predicts test score. So if we want to pick our dragons that we've trained, we want to pick longer dragons because that's predictive of their test score, right? That'd be a good idea. So at this point, we're going to ask the AI a slightly more complicated question. What we want to do is we want to say, well, is this really true, this conclusion we just came up with, right? Remember, we had our 8 different mountain ranges, and it's possible that that variance is driving this effect and that we don't actually see a relationship between body length and test scores. And instead, it's an artificial relationship being driven by the covariance among the different mountain ranges. So to dig into that, one thing you could do is you could look at the visualization, the figure of body length and test score separately for each of the mountain ranges, right? That's something you could do. And to do that, and I'm just going to run through this like live with you instead of you doing it per se, because I feel like we're going to run out of time. So we're going to ask Better Code AI to create a ggplot figure that depicts the relationship between body length and test score, but is facet wrapped by each of the 8 mountain ranges. Facet wrap is a term in ggplot that means it's going to separate the figure as a function of the mountain range. So you'll notice that it's done something interesting here, which is that it's deleted our other ggplot figure. And that's just kind of unfortunate. And it just has a habit of doing that. ChatGPT has the same problem. If you ask for like a ggplot and then ask for another ggplot right afterwards, it tends to just overwrite the original one. So you are going to run into issues, right? This thing is not going to do everything for you. You have to think along. And part of thinking along would be taking this code and copying it manually and adding it to the code that you already had saved in RStudio. So if you go back to RStudio, right, we have our code up to here. So we're just going to manually add this second ggplot figure since it deleted the previous one. It's not perfect, right? Like they're still working on it. It's still learning. And we could rerun this entire thing. And again, we have to select dragons. And we'll get an additional figure. So we still have the histogram and that relationship, that simple plot we looked at. But now we also can see the relationship between body length and test score as a function of the different mountain ranges, right? We're looking at the different grouping. We're looking at the grouping variable in terms of the mountain ranges, and we're looking at the relationship that we're interested in at each of the different mountain ranges, so separated by mountain range. This is as if we looked at the relationship between teacher and student at each different school separately, rather than just collapsing across them. And we'll notice something that is a tiny bit troubling here, which is that, like, why is this concerning actually? Can someone help me out? Why is this concerning for our original conclusion that body length predicts test score in dragons? Anyone?
So here it seems across different mountains, the mean and variance may differ.
Right. So said a different way, there is some kind of variance associated with mountain range, in the sense that some mountains just have bigger dragons than others. And those mountain ranges seem to also have higher test scores than others. But there's actually no relationship between body length and test score within each of the mountains, right? None of these correlations really look like, none of these scatter plots really look like a positive correlation, like a positive relationship. They look kind of random. So the reason potentially that we're seeing a link between body length and test score has nothing to do with body length and test score actually being related. It just has to do with the fact that mountains that have bigger dragons also have higher test score dragons. But that might be just because of the resources in those mountains, right? So, you know, one mountain might just be really high in resources, and therefore there's longer dragons and they're also smarter dragons or whatever. But that doesn't mean that in the population of dragons generally, that length predicts intelligence. It's as a feature, it's as a function of variance in those locations. So if we were to go out and publish our paper and say, oh, we did a linear model, look, and we found that body length of the dragon predicts the test score, we'd be flat wrong. And that would suck, right? Because we don't want to publish type 1 findings, type 1 errors, right? That would be bad. And that's the importance of mixed modeling, as we need to take into account that our data may be structured in a way that it's grouped in certain groups that have confounding variance, right? That our observations are not independent. They differ as a function of the school or the mountain range or whatever it may be. Super important point. Okay. So yeah, the answer is if we look at the link within each of the mountain ranges, it doesn't look like our findings are actually real. We assume the mountain ranges are independent, but they aren't. Body length varies by mountain range. So now that we know this, we know that we need to create a mixed effects model instead of a linear model. And we can do that with our lovely AI tool, right? We can just ask it to add a mixed effects model to it. And it will do it for us because it's smart. All right, so we prove the changes, and we can just take out those new lines of code from 27 to 29, and we can add them to our studio file, right? And we could rerun everything, why not? Okay, and we'll see that something has changed, which is that at the end of the output, we have this summary of our mixed effects model. So mixed effects is LMER instead of just LM. And what this line of code says basically is this is the outcome variable, the test score. The body length is a predictor, but there's this addition to the line, which is 1 and then this vertical dash mountain range. And what this syntax notates is that the variable test group and body length, they are grouped by mountain range. There is a random effect in our data that is mountain range, right? We didn't collect all the dragons randomly. Nothing was, in a sense, randomized. Instead, we collected them at 8 different sites, mountain ranges. And so we have to take into account the variance in those mountain ranges in our model. And this does that. So random effects in linear mixed models are notated in this parentheses 1 vertical mountain range way in terms of adding a grouping factor. It gets much more complicated, and you can add other things like sites and blah, 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 but that is kind of outside of the scope of this. But you can, again, go do the Dragons workshop if you want to learn more about it, right? Because we could have sites in mountain ranges, like we could have, if this was a different data set, we could have, you know, counties in US states, for instance, right? That's another nesting variable. But for here, we're just worrying about the mountain ranges. So now we've accounted for the random variance of mountain range in our model. And you'll notice that something concerning has happened, which is that body length 2 no longer predicts test score. So if we go to the output here, right, we'll see that the estimate is quite a bit smaller. It's no longer 9, it's like 0.5. The t-value is pretty low. The p-value isn't on here because I didn't run Elmer test, but it doesn't matter. You can pretty much tell this is not significant, and we'll see that in a second in a prettier output. So one last thing I would add to, let's say, our code that we created in AI is to have a prettier output of our final table, right? Of our final model. And to do that, we can use the function tab model from stjplot to make a kind of prettier to create a prettier output of the mixed effects model we just created. And again, we just ask Better AI to code it for us, and it will add it to the end of our code. And again, we just approve. And all it's done is add these 2 little lines. So comment and the 1 line of very short code. And we can go back to our RStudio, we can add it. And let's just run only that line. It'll create a nice table for us here on the right, where you'll see the p-value is 0.673. So body length no longer predicts test scores when we take into account the variance of mountain ranges. So we need to take into account our grouping variables. We need to take into account the grouping variables and nested variables in our data that exist, right? If we're, let's say, doing a study on whether manager attributes predict employee performance at different companies, we need to include company as a random effect. One quick rule of thumb, random effects have to kind of be bigger than 5 or 6 categories. So if you only had 2 different companies or 2 different classrooms or 2 different mountain ranges, that doesn't really work. You can't really add them as random effects. But again, this is kind of above and beyond what we're talking about here. But this pretty output looks pretty good, right? We could add it to our paper or whatever. And the kind of takeaway, though, more importantly, is that this entire code that we have here, right, that does quite a lot. It creates this output. It runs a linear mixed effects model for us. It runs a linear model for us. It creates a histogram. It creates a ggplot of the general relationship. It creates a ggplot of the different mountain ranges, right? It does all these things, and we didn't write a single line of code. That's pretty cool, right? Now, this is not to say that you shouldn't learn how to code and you shouldn't learn how to understand these things, right? The AI will make mistakes and you will need to fix them. But there are ways to use AI to also learn how to code, right? You can ask it how to learn different things. You can ask it how to learn how to code in R. You can also go backwards, which is very neat. So that involves, you could, for instance, copy the code into ChatGPT and ask it what the code does. You can do this with Better Code AI as well, but let's just do it with ChatGPT. So this is actually the final full prompt. If we combine all the things that we typed into Better Code AI that I just went through, this is the final prompt. And it's actually much better, in my experience, to create a longer prompt than to do it piecemeal the way we just did. So the piecemeal thing is just a demonstration. It's usually better to just do it in this gigantic form. One really good reason why is because then you don't have to wait for it to type the whole code again and again and again and again, which takes forever, right? So I could take this entire prompt and I could go to ChatGPT, let's say, have it open already. And I could be like, do that for me. And bada bing, bada bing, bada bing, bada bing. Check it out. Ha, so cool. It just created the entire code we just created, right? In one go, relatively quickly. Pretty neat. So let's do the backwards thing, right? If we take the code from R and we ask it, let's say, can you, is it typing? I can't really see. Yes, it's. Can you explain the following code to me? Let's do that. All right, sure. Let me break down the code for you. These lines of code check if the required packages, ggplot, blah, 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 are installed. If they are not installed, then they will be installed using this. The required function, blah, 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 blah. This code opens a window for the user to select the CSV file. This code creates a new variable, body length 2, and dragging strings by scanning the variable, do. I mean, this is pretty neat, right? So if you find code, you don't know how to code, let's say, you're not that experienced, you want to understand somebody's open source code that they used on a project because you're trying to do something similar. Just chuck it into ChatGPT and ask it to explain it to you. This is a better way of learning, right? I could say, oh, it's a horrible idea just to use artificial intelligence. You should learn how to code because the AI will make mistakes. But sure, the point there though is that you should use both, right? You should try to integrate both, and that by using the AI, you can also learn how to code, right? You can also learn how to understand different lines of code, right? You can ask it something like, why is this line of code like this and not like this? And it will tell you, right? What's the difference between this structure or this structure? What's the difference between this variable and this variable, right? That interaction should be integrative in terms of both learning, but also in terms of asking it to make your life more efficient and easy by creating the code for you. So it should kind of be a give and take, a back and forth. So I don't think AI should just be used to just create code for you that you don't understand. That seems like a bad idea. You should then also use it to try and understand the different things that it has created for you, right? Okay, very cool. Okay, here are some tips. I mentioned this. It's usually better to write a long prompt first and then type it in because then you don't have to wait for it to load again and again and again. And it also won't delete things. Remember when the Better Code AI just deleted our previous ggplot, our previous figure? It won't do that if you put it all in the same text. Yep, what's up?
Also regarding tips, I'm using a MacBook and I had to tell Better Code AI that I'm using a MacBook because the code is a little different for R, I think, because it didn't work at first, and then I told it, and it kind of changed a bit, and then it worked. That's what it was for me. I don't know.
Is it because like file choose doesn't work on Mac? It should.
I don't like. I'm not an R user, not experienced, but it didn't work, and then I just told it that I'm using a MacBook, and then it fixed things, and then it worked.
I mean, that's pretty cool.
Yeah. Something to maybe keep in
mind. No, but that's perfect, right? I mean, that's
but
that's exactly the right interaction, right? Rather than just blindly being like, code this for me. You're like, oh, but wait a second, could it be this? And then it's like, oh, let me try that, right? Like that's the way to interact. That's brilliant. That's a great example. Yeah, we'll also try to be as detailed as possible. Right? You remember to tell it you're in R, right? It knows a lot of things, but it doesn't know everything that you know. And it doesn't know everything that you want. And so just try to be as detailed as possible if you can in the prompts. If the AI has made a mistake, point that out and ask it to correct itself. I think that's kind of what Henrik was just saying somewhat, right? It will make mistakes. It will create code that occasionally doesn't work. If it does, mention that and be like, this doesn't really work. maybe the file path is different or the R code Windows is not applicable for Mac. Yeah, that might be the case. Okay, I'll update that in the future. Yeah, so again, it's a conversation with the AI, right? You can point out that it did something wrong, and often it will correct it and do it correctly. Sometimes it won't, and we'll just insist that it's correcting it while doing the exact same mistake again and again and again. But often it will fix whatever mistake it's made. If you're really going to try to do this and and you want to use R a lot, you have a new project coming up, whatever, I would probably recommend spending the $20 to have a pro account on ChatGPT. It's just exceedingly fast. And other things just take a while, and one thing is, in the sense of what I was saying about it making mistakes, but also being able to fix those. Don't overestimate its abilities. It won't be able to do everything. If they're doing something very complicated, that's pretty nuanced, it's pretty unlikely it will get that right. But then also, don't underestimate it. It's able to respond in pretty cool ways if you say that it did something wrong, or if you want something else or something like that. So it both has the weird thing where it kind of overshoots what you expect a lot of the time, but also undershoots a lot of the time. So I guess this is still part of the learning process for us of how to use this software. And don't forget, it's a learning process in the sense that you will also get better at asking the right types of questions in terms of getting the right types of answers in terms of producing code or asking what code looks like or whatever. Use cases are obviously your own research. I also think in teaching, this is pretty neat. Students are super scared of R. They don't want to download it. They, don't want to work on it. And then they'll try to do some analyses in Excel and tell you that they did an R or something. But this helps, right? Like, it really does. I actually don't think we should shy students away from using ChatGPT or think it's cheating in any way. I think if that resource exists, people should be able to use it, because in the real world later, people will be able to use it, right? No company is going to be like, you can't use ChatGPT, that's cheating, right? If we're actually trying to teach students to achieve things, to be able to accomplish things, to be able to create projects, to be able to create products, we should encourage the use of new tools that exist rather than discourage them. Last couple things before Q&A, integration in the future. So IDEs, or coding platforms that have integrated AI, are kind of the holy grail, the thing that we would love. We have been bouncing today between Better Code AI, ChatGPT for a second, and R, and RStudio. Wouldn't it be much nicer if there was an AI just in RStudio? It would. So there's 5 options for these kind of things. There's one thing, which is the manual switching that we've been doing today. There's another thing, which is an add-in on RStudio that Michael Navard created that creates a little shiny app in your RStudio that can be used as a kind of ChatGPT requester. It's quite neat. I'll show you an example of that in a second. But it also has its issues. VS Code and GitHub Copilot is super cool, but very, very hard to set up. Replit and Ghostwriter, don't use it for R. It won't load certain packages that you will definitely need. So don't make this mistake and go down that rabbit hole like I did. And the last thing is probably using Python and GoPilot, and Copilot is the best thing. But for R, we're still kind of right at the beginning stages of this stuff, so it's not perfect. Let me show you some examples. This is the add-in that Michael created. It's pretty neat. So it creates this little shiny app in the viewer in your RStudio. You can also set the programmer proficiency and the programming style, which is kind of neat. And now you don't need to ask, like, in R, can you tell me this? Because it already assumes it's an R, right? This is actually a fairly complex task that it's asking it to do, or that he's asking it to do. And you'll see that it's created this lovely little shiny app for the user. So you just copy that code over like we've been doing before, and you can run it. Quite fun. He immediately runs into a bug. This is a common bug that that the artificial intelligences run into that I've found, which is that they forget to load certain packages. So you'll notice it just forgot to load dplyr here, which is a package required in this code. And if you add it, then everything looks good. That's just something to keep in mind. But this is pretty neat, right? So it didn't have to switch programs, didn't have to go online or whatever. It's all inbuilt, which is pretty nice. One unfortunate aspect of it is that it doesn't recognize the pro version of ChatGPT, so it's a bit slow. This is an example of R and Copilot in Visual Studio. You'll notice it's a little different from the AI technique we've been using, where we just type questions and get code in response. The Copilot instead, once you write a comment in your code, which is that hashtag, right? He's writing a comment right now. It will suggest for you the code based off of the comment you just wrote, which is pretty neat. It's a lot faster. So, right, he's gonna write a comment. Wait, I'm gonna get to the comment real quick. Pumpkins, blah blah blah. Let's go. Here's an example. So comment, display 5 random rows, and it creates the code for you, and you just press tab. It's pretty good. It's really, really pretty good. All right, average, high price by package and color, and it creates the code for you to do that. This is the coolest, right? But Visual Studio and R is annoying to set up, and you can't use R Markdown in it. So, but whatever. Riplet will skip because it sucks. And then finally, one cool aspect of writing everything in a natural language like English and then chucking it into these AIs is that you're not kind of stuck in a language, right? If I write the same kind of thing here that we just did, and I say, can you write me code in Python that reads in dragons.csv, then runs a linear model, blah, 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 the stuff we just did, I can do that. I can write that into ChatGPT and it will definitely create that for me. So now I can very quickly change between languages if I want to, which is pretty neat. All right, finally, some serious warnings. The serious warnings are maybe not that serious. Maybe I'm being dramatic. But they basically involve a couple things. The first thing is they make mistakes that you're not going to notice per se unless you know what you're doing. And then they will be pretty adamant about their mistakes. They'll be like, no, I'm right. And you'll be like, no, but that's wrong. And they'll be like, I'm so sorry, let me try again. And then it will do exactly the same mistake again. That's kind of this idea of being trustworthy. It can hallucinate facts and confidently assert wrong things to be true. So that is something to take into account. One thing we also talked about is being deterministic, right? If we run the same prompt, we're going to get different responses every time. It's an artificial intelligence. It's not meant to give you the right answer. It's meant to give you a good human brain type answer. So it's always going to be a little different, right? Okay, cool. That's it. Thank you for attending the talk on using AI to code in R. Hope you found it informative and useful.